Welcome. Well, what I want to do now is actually I'm going to use a this graphing application to explore the trigonometric functions or explore the graphs of them. And just to start off, just let you know this application I'm using is from gcalc.net. It's gcalc.net. It's not mine, but I want to give them credit because that's what I'm using, and I hope they don't mind. So let's start off just graphing some functions. Let's start off with the sine function. So let's say sine of x. I hope y'all can see it. See, I'm typing it in up here. So sine x. Let me graph that. Look at that. Look how nice that looks. So let's interpret this. So it's oscillating between. Let's just go point by point. I guess is the easiest way to do it. So when x is equal to 0, what is the value of this function? Well, if we look here, the value of the function is. Let me actually trace it. When x equals 0. And it has it written down at the bottom of this gray area. So when x is 0, y is also 0. And if you remember when we looked for the definitions in the unit circle, that's what we got. That the sine of 0 radians is 0. And now as we move on, or move along the curve, I have the trace function on. This is when x is equal, if we look in the gray area at the bottom left, it says 1.57. But what is that? If you're familiar with the 1.57 is more commonly known as what? It's half of what famous number? Right, it's half of pi. Or we're at pi over 2. And if you want to convert pi over 2 to degrees, that's 90 degrees. So when we're at the angle of pi over 2 radians, the sine function is equal to 1. And if you go back to some previous modules, you'll remember that that's exactly what the sine function was equal to when we looked at the unit circle, because we were essentially at the point 1, 0. I hope it's not confusing that I keep referring to the unit circle that you can't see, but we'll keep going. But one thing I want to introduce here is the concept of the period or the frequency of this sine function. Notice it's pretty obvious to you at this point that the function keeps repeating itself, right? It goes from 0, moves up to 1, goes back to 0, goes down to -1, then goes back to 0, and then repeats again. So the period of this periodic function, because that's what we call a function that keeps repeating, the period of this periodic function is this distance from here to here. And what's that? Well, that's 2 pi radians. And does that make sense? Well, sure, because 2 pi radians is one complete revolution around the unit circle. And then it repeats again. And it goes the other way. You go 2 pi radians backwards and things start repeating again. Pretty interesting, right? And another thing, notice that what two numbers does it oscillate between? It oscillates between +1 and -1. And that makes sense because in the unit circle, you can never get to a point on the perimeter of the unit circle that's larger than +1 or less than -1. And that's why the sine of x keeps oscillating between these 2 points. Let's do the cosine of x. And actually, I'm going to leave the sine of x there. Interesting. It looks almost the same, but it looks shifted. It actually looks shifted to the left about pi over 2 radians, and that's actually the case. So let's first think about why we figured out before that sine, actually it looks like this program is still tracing the sine function, that sine of 0 was 0. But if we look at the green function, the cosine of 0 radians is actually 1. And let me see if I can, let's see. No, I see. I don't know how to trace the cosine function, so I'll just do it here. The cosine of 0 is 1. And why does that make sense? Well, the cosine is the x-coordinate on the unit circle. And when you have 1 radian, when you have 0 radians or 0 degrees, you're at the point 1, 0 on the unit circle. So 1 is the cosine, or it's the x-coordinate, and 0 is the sine value. And if any of this is confusing, review the video where I use the unit circle to solve the various values of the trig functions. And then this should make sense. And notice that this has a period similar to the sine function, right? It starts at 1, it goes down to -1, and then comes back to +1. And it takes 2 pi radians to complete that cycle. And just like the sine function, it's oscillating between 1 and -1 because it can't really on the unit circle, you can't get to a point on the perimeter that's higher than that. And now to really hit the point home, let's do the tangent function. I think this one might surprise you. Oh, look at that. So the blue line is the tangent function. And why does it do this crazy thing? Well, if you remember, the tangent function is equal to the y over the x on the perimeter of the unit circle. And or since the y is the sine and cosine is the x, it also equals the sine over the cosine. So here, tangent is 0 whenever sine is 0, because that makes sense, because tangent is equal to sine over cosine. So it makes sense that when sine is 0, tangent is 0. But then, as the sine function becomes greater and the cosine function becomes less, the numerator in the tangent function becomes greater because the numerator is sine. So we get larger and larger values all the way to the point where the denominator of the tangent function, or which is the cosine function — I think this is probably the most confusing module I've ever said because I can't really write these things down — the denominator goes to 0, right? This cosine right here. And then tan spikes and it actually approaches infinity. And if you look back at the unit circle, that actually might make a little bit of sense. But like the other functions, actually the tangent function has a period of pi instead of pi over 2, instead of 2 pi. And I'll leave that as an exercise for you to think about. But with that drawn out, I'm not going to explore something else. Let me reset this. Yes, I really want to reset. I drew the sine function before. Let me draw the sine of, let's say, 2x. Whoops, that's not right. Sine of 2. Maybe I need to put some parentheses in. Oh, there we go. Actually, let me reset it. Yes, I want to reset. So first I'll draw the sine of x, and then I'll draw the sine of 2x. So what's the first thing you notice about the difference between these two? The brown one is sine of x, and the green one is sine of 2x. Well, they both oscillate between the same two numbers, and just so you know, that the height of the oscillation is called the amplitude of this periodic function. So in both cases, the amplitude is 1 because they oscillate from 1 to -1. So the amplitude is 1, but their period is different. Sine of x takes 2 pi radians to complete one cycle, while sine of 2x only takes pi radians to complete one cycle. So it actually completes it twice as fast. And I want you to sit and think about why sine of 2x has half the period of sine of x. And you could probably guess what happens if I type in sine of 3x. Actually, let's do sine of 4x. It should have half the period of sine of 2x then. And it does, even though this is probably a very confusing graph. So let's explore. So I think you understand what the coefficient of the x term does. When you have a larger coefficient, it kind of speeds up the cycles. And let's explore a little bit more. Let's start off with sine of x again. And now instead of making the coefficient larger, let's make the coefficient less. Let's make it sine of 0.5x. Look at that. Now all of a sudden it takes 4 pi radians to complete one cycle. And I want you to think about why that is, because we're now slowing down how fast it cycles through the angles. Now I want to start playing with the amplitude. So we had sine of x, right? What do you think will happen if I put in 2 times, that's 2 times sine of x. So here, the period is the same. It's still 2 pi, but notice that it oscillates between 2 and -2 instead of between 1 and -1. So whatever the coefficient or whatever the number is in front of the sine or the cosine function, that actually affects its amplitude. And similarly, we can look at 0.5 sine. Let's say 0.5 sine of 2x. Interesting. So now it only goes up to 0.5 and down to -0.5. So its amplitude is half, 1/2, or 0.5, and it's also oscillates twice as fast as the sine function because it was 0.5 sine of 2x. I think that's all the time I have now. I have a feeling this might have confused you more than helped, but I'll still put the video up just in case it's helpful for someone. But in the future, I might actually record another video where I can actually write things down so it doesn't confuse you as much. So if it confused you, I apologize, but I hope it was helpful. See you later.